Good morning. Can everybody hear me? We'll just wait here about a minute and a half or so for everybody to start to come in here. It's just about 11 o'clock. Yeah, if somebody let me know if the audio is working. Let me know where you're from. How many of you guys liked the sunshine yesterday? It's nice out there right now. My goodness, almost 60 degrees, lots of sunshine. Too bad it's not going to hang around here. All right, just pulling up the feed here on the other computer. It's taking a little bit of time here, but we'll get going here real shortly here for us. All right, good. Sounds good. Where are you, so it sounds like the audio is working just fine. Yeah, let me know where you're watching from. So from Toledo. All right, things are looking good. So today we're going to talk about lightning. So I'm really excited about this. Archbold, Sylvania, Delphus, Allen, Michigan, Rossford, Wyandotte County. By the way, too, if you do know somebody, even if they're not in Northwest Ohio, but you know maybe a child that really likes weather or they would be interested in it, feel free to share it with them. Let them know. We're not going to just keep this to the Northwest Ohio. Anybody can watch. It's totally fine. Swanton, Bryan, yeah, thanks for joining us. Oregon. All right, sounds good. So we're going to talk today about lightning, the science behind lightning. And I think this is one of my favorite topics because lightning is really kind of a chaotic thing. So this is Getting Schooled. We've been talking about severe weather all week. And if you have missed the tornadoes or the hail or anything like that we've been talking about, you can find it either right here on the 13ABC Facebook page, or also you can go to my Facebook page, and it might be a little easier to kind of sort it out there. But look under the videos and you'll find it. It's still up there on the site. So we're going to talk today about lightning, and here's kind of a look at what we're going to be talking about next week. So tomorrow we won't have anything, but then next Monday, Tuesday, and Wednesday, it'll all be about earth science. We'll talk about volcanoes on Monday, earthquakes on Tuesday, and then wildfires coming up next Wednesday. So not exactly weather related. They're kind of close. They're still in that earth science category. So we'll talk more about that next week. But for today, so this is a couple lightning pictures, and lightning comes in all kinds of different varieties and forms. So it's electricity. It comes from these thunderstorm clouds that get organized. And this is a lightning photo taken back in Arkansas, where that environment on that night was a lot like it was here. It typically is here in like June, where it's really rainy. A big thunderstorm complex comes through, and there's some lightning all over the place. But a lot of it was just these flashes. It was raining so much you couldn't see a lot of the details. But in this particular case, you could. And this is a pretty close strike that happened. This was back in 2012. It was in about north central Ohio, so just south of Findlay. And you could just see these lightning strikes zipping across the sky, but this one never touched the ground. It stayed up in the clouds. So we'll explain why that's the case and why it just stayed up in the clouds. But that's one type of lightning. And then this is out towards Arizona, and they don't get lightning as often as what we get it typically, but when they do, they usually can see it really well. And that's because the space between the ground and the cloud is much larger, and so you can kind of see all the lightning as it comes from the bottom of the cloud and actually hits the ground. And this is another one out in Arizona several years ago. And this has all happened at the same time. There's two big lightning strikes that took place. So I want to get right to some of the science behind it. So I'm going to take you over to this video. I got two different videos to show you today, and we'll start with some researchers. Yesterday I was showing you some storm chasers, and they were watching what happens with hail. Well, these guys, they want to learn more about lightning and how it forms. So they got these big, powerful cameras here, and they're looks like up in a hotel room or a skyscraper or something like that. And they're in a safe spot inside that building, but they are filming outside of it. But what they're trying to do is they're trying to look at these lightning bolts as they happen, but they are looking at it in really fast cameras, and then they're slowing it down. Did you see that? Look at that. It's just like kind of a spider web crawling all the way down to the ground. And so what these cameras are doing is that they're being able to look at this lightning in super slow motion, And we don't get to see that. When we see it, it happens so fast. By the time it basically happens, it seems like it's over. And it's really tough for us to see the inner workings of this. So notice in these clips that are kind of running over and over again, you get that like almost that spider web, that crawler with the lightning. It branches out, goes from the cloud and keeps branching out, keeps branching out, keeps branching out, and finally hits the ground. And after it hits the ground, you see that one connection flash back and forth. So there's the big flash back and forth. And there's your big spider kind of all the way crawling down to the ground. And then you get that big flash. So there's a lot of things that happen in only about a quarter of a second. That's it, about 1/4 of a second. So a really, really short period of time. And I'll walk you through it on the graphic here coming up. But basically, this electricity kind of crawls down towards the ground, and it's trying to find the best spot. And once it makes a connection with the ground, the electricity goes back and forth, up and down, sometimes several times when it gets into that motion, which is really, really neat. This is really slowing it down. So it was the same lightning strike, and then you can just see that one bolt up and down, and that's where that electricity goes. So there it goes down. There's your electricity back and forth. So this video clip will show basically what's happening. You got this cloud, and you've got some electricity in that cloud, and as it continues to grow, that electricity becomes a little bit more powerful, and that charge builds up, and eventually it leads to where we can get some lightning. So I'll break it down even more. We've got some graphics here that do a really good job of showing that. So there's some lightning there in the background. But so let's take it right. So as soon as that cloud, it gathers a lot of electricity. Remember yesterday I was talking about the hail and how it's almost like a washing machine where there's like rocks thrown in and a bunch of water and everything else, and everything is just kind of spinning up, and it's real chaotic up there in the top part of that thunderstorm cloud. Well, that helps to build charges in the top part of that storm cloud. And when that happens, it's kind of like if you've ever touched maybe a doorknob and gotten zapped by static electricity, or if you've ever taken a balloon and then take it on your head and rub it, and then all of a sudden your hair stands straight up. Has anybody ever done that before? Well, if you have, that's the same thing as that static electricity. You're taking that balloon, you rub it on your hair, and it's building up that charge, kind of like the same thing with these storm clouds as they continue to move over the landscape. And so the first thing that happens is that charge starts to build up at the bottom of the cloud, and these electrons, these little pieces of electricity, they start to crawl down from the cloud. And we saw that on the video, and it just kind of keeps crawling down. It's trying to find the best path down to the ground as it possibly can. So it'd be like if you were going, maybe taking a hike in the woods, but nobody had ever been in the woods before, and you wanted to go from the top of the hill down to the bottom of the hill, down to the river or a waterfall or something like that. But nobody's made a trail before, and you're just trying to go through the woods and find the best way of getting down to that river. Maybe you go one direction and now you ran into, some trees or something, then you kind of go a different direction. The lightning is just trying to find the best path it can through the air to get to the ground. So it's kind of trying and feeling out several of these different little spots. And then finally, once it makes a connection with the ground, that's it. That's the quickest and the best spot it can, and then it puts down that charge. So what we see, it looks like all one lightning strike, all happening instantaneously, but really you get kind of that forked look, and then it makes that connection, and then you get the lightning strike, and you get several pulses back and forth all at the same time. And all this happens within less than a second, and usually it's less than a quarter of a second. These super-powered cameras are pretty remarkable because it takes you about a quarter to half second even to register that a flash of lightning or something is happening for you to even press the trigger on that camera, which is pretty neat. So there's lots of different, I showed you some lightning pictures before, different types of lightning and what it looks like, but this is a graphic kind of shows you what can happen. And lightning is really, really neat because it isn't just one strike and it's done and that's it. Lightning comes in all kinds of different varieties. You get what's most common that we see all the time is that lightning goes from the cloud down to the ground. Sometimes, and I'll circle it here on the graphic. So this is what we talk about most often with that lightning coming and striking the ground. It hits a tree or something like that. Sometimes, believe it or not, the lightning starts at the tree and works its way up to the cloud. And actually, that happens on our TV towers more often than it does on about anything else. TV towers in general are notorious for this. So the charge builds up first on the tower, and then the flash lightning goes up and crawls up towards the cloud. It's really neat. It's rare. It doesn't happen very often, but it usually happens on really, really tall points. It typically wouldn't happen on just a tree, but like a big TV tower, it goes really high into the sky. That happens more often with. And then we get these lightning bolts that happen inside the cloud all the time that don't hit anything other than just different spots in the cloud. And sometimes a lightning jumps from one cloud to another cloud. That's pretty uncommon. That doesn't happen too often. Sometimes you get the lightning that just zaps into thin air. So that happens sometimes. So it's a pretty neat stuff that can take place with the lightning. So there's several different things that can happen inside of it. Here's another cool thing too, is that when we get lightning, you can tell how far away it is. You don't need any special equipment. The only thing you need to know how to do is how to count. So if you can count, then you know how far that lightning is. Every 5 seconds, if you just count to 5, after you see lightning to the time that you hear the thunder, you can figure out how far away it is. So if you count to 5, that's 1 mile. If you have 10 seconds in between, or you can count to 15 in between, that would be 2 or that would be 3 miles, depending on how it is. The speed of thunder is pretty fast. It's about 750 miles per hour. But the speed of light is much faster than that. So if lightning and thunder happen at the same time, that's usually not a good sign, because that means the lightning is striking right around you. It's really, really close. But if it's 30 seconds or something like that, well, then you know that it's several miles away at that point. So that's a really neat thing that you can do. Again, you see the lightning and then count and wait until you hear the thunder. And it doesn't take too long, so about almost five seconds. If you're trying to do the rough math on it, get real specifics, like 4.7, 4.8 seconds usually. But again, that's how far it is. Now, if the thunderstorm gets far enough away, we get this question all the time. I don't know if you've ever heard of heat lightning before, or if you've ever heard anybody talk about heat lightning. Heat lightning, the only thing that is lightning that you can see, but doesn't have any thunder with it. And what happens is that eventually that thunder sound dissipates, or sometimes the sound waves actually go up into the cloud a little bit above our head. And so we don't hear the thunder, even though the thunder is still there. It's closer to the lightning, but that's still real lightning. It's just happening really far away. So if you can see lightning, but you don't hear it, it's usually pretty far away from you. Here's another really interesting thing. And when I was a kid, when I was a lot of your age, probably the age of a lot of you that are watching, I would usually hear these really loud thunderstorms when I was trying to go to sleep, or maybe it was overnight, and that would scare me. That would wake me up, and I would think really bad storms are coming. If I heard really loud thunder, I thought maybe a tornado was coming. But usually, if you hear really loud thunder, the risk for a tornado is actually lower, not higher. And there's a reason for it. So that usually you get what creates really loud thunder is a layer of some warmer air that's above our head. So it's a little colder at the ground, and the air above our head is a little bit warmer. And what that usually means is that the storms are a little higher off the ground, and that usually makes it tougher for those storms to produce a tornado. But that warm air kind of acts like a lid. And when that lightning happens and the sound waves go up, instead of the sound waves starting to go up into the atmosphere away from us, they get shot straight back down to the ground. It makes it kind of echo. It makes it even louder, and it certainly can be really scary. But a lot of times that also means that the storm doesn't have as much severe weather with it as what it could if it was, say, in the middle of the day and maybe the thunder wasn't as loud. So that's kind of an interesting thing to think about, is that those storms that are usually really loud at night sometimes aren't as scary or severe as what they may seem like. So I'm going to take you back over towards our other computer, and I want to show you. Looks like our video is still playing here. I'm going to show you a couple more neat facts about lightning here. There we go. Lightning's hot. It's really, really hot, and so one of the things, I mean, I've already got the answer on your screen, but a lot of times when I do go out to schools and talk with groups of kids all the time, I ask, how hot do you think lightning is? And I get really hot, or as hot as the sun. It's not only as hot as the sun, but it's a lot hotter than the sun here. It's about 5 times hotter than the sun here. 50,000 degrees. So we don't want to get struck by lightning. That's not a whole lot of fun. You don't want to be touched by anything that's 50,000 degrees. It's really hot. It's got a lot of electricity with it. But the average lightning strike, as I mentioned, is only about a quarter second long. That's it. And there's usually several flashes back and forth. And because it's so quick, it actually, most people that get struck by lightning, 90% survive. Sometimes they can get burned. It's not something that you want to happen, but typically it's something that doesn't, it may send you to the hospital, but most people recover from it. And the taller that of an object that you have, the more likely you get struck by lightning. The Empire State Building gets struck by lightning about 24 times every single year. That's a lot. And so there's a lot of electricity that ends up hitting. I've showed you some maps over the last several days on Tornado, where Tornado Alley is at. I've showed you some maps here of where Hale Alley is at, which is out like towards Colorado and Kansas. And here's Tornado Alley right here. And then yesterday I was talking about Wind Alley, and that actually comes right over us. That's right through the Midwest. But here's a look. If there's a lightning alley, where would it be? It would be down here in Florida. They get a lot of lightning. Actually, I think Florida, for the most part, is underneath my picture here. So I'm covering up where I just circled. But Florida gets a lot of storms. But another spot that gets a lot of storms, and one of these days I'll talk more about this, but it's out in Arizona. They only get lightning typically in about late June. Typically it's July, August, and September, but it's the monsoon season, and they get a lot of lightning out there. But we still get about 35 days a year. We're right here where that blue circle's at. There's about 35 days out of the year where we do get some lightning, days with lightning. And that usually happens for us in May, June, July, even August is usually kind of in the same boat. So did want to talk a little bit about, before we get to the questions today, I did want to talk about safety from lightning, and severe weather in general, even tornadoes. For lightning, if you're inside your house, you're in a safe spot. You're in a good spot away from it. If you're outside, you want to get inside. That's the thing. Your house is a great shelter, acts for a good protection from lightning, but you want to stay inside for at least a half hour after the last point that you have seen lightning or heard thunder, either one. But definitely, if you've seen a lightning bolt, you've got to wait a half hour and to stay safe. Wind, I showed you a picture yesterday of wind and hail. If you're inside your house and away from windows, you're in good shape with that too. Tornado safety, that's when you want to get to that safe spot. And how many, you can let me know too in the chat, how many of you guys know, where do you go? Where's your safe spot? Where's a spot that you would go when it comes to a tornado? If a tornado warning's out, we come on TV, we go, mom or dad's looking at their phone and they get their app and it's alerting you to a tornado warning. Where would you go? Where are some spots? Let me know here where you would go. Of course, I've got some spots here up on your screen too. Maybe these are spots where you go. Maybe you've got a basement. You've got a storm cellar. Those are great spots. If we were in school or if we were at a church or something like that, the plan would be different. And I know a lot of the tornado warnings and tornado drills that we have at school, we're trying to get inside the halls a lot of the time. We're trying to get away from those windows in the classroom in particular, because that's a safe spot. We want to try to put as many walls between us and the outside as we possibly can. But when it comes to our homes, even if we don't have a basement, we don't have a storm cellar, a lot of times closets are a good spot to go. Bathrooms are great because they've got extra piping in the wall that helps to protect us. And even when I worked in Arkansas for a few years, and we had some really bad tornadoes down there. We had a strong EF4 tornado, and it was 1.25 miles wide. It was an enormous tornado, and yet Arkansas doesn't have a whole lot of basements. So the folks there, they had to get into their bathrooms, or sometimes they just went to their hallways. And you know what? They survived. Even in their safe spot, go into their bathrooms. Not only did they survive, they didn't have any injuries at all because they knew where they needed to go. And even the interior part of their house, it was fine. The tornado came and it took off some of the walls, it took off the roof, it did a lot of damage. But their bathroom, most of the time, was at a safe spot. Those closets, the interior hallways, were a great spot to stay safe, and they were able to ride out the storm there. So as scary as it was for them, they were fine because they knew what their severe weather safety plan was, which is a great thing. See, downstairs, Jennifer says, downstairs bathroom from Andrew. Can lightning strike you in your house? Lightning can try to get through your house in some cases if you're maybe touching something metal. But typically what happens when lightning hits a house, the electricity from that lightning strike actually goes into the wiring or something like that, and it's trying to find the quickest and easiest way down to the ground. So the lightning is kind of going through your house in certain spots, but it's not going through you if you're in your house, which is the great thing. I mean, your house acts as a big protection there. Crawl space under the house, it's a great spot. Yeah, I did. That's one spot where I don't think I have in the graphic, but the crawl space is just as good as a storm shelter and just as good as a basement. You're still at the lowest possible spot that you want to go. So at this point, I think we've run through the majority. If there are questions that you've got about lightning or severe weather, let me know. We're going to run through those right now. But I think that's the majority of what I was wanting to get to on lightning. I think it's a fascinating topic, absolutely amazing. Usually the tallest object, if a lightning strike is going to hit, it will hit that tallest object. But there are exceptions to the rule, which makes it a fascinating area of research that's still being done. So just like tornadoes, there's a lot of things that we know, and there's a lot of things that we still have to learn. Same thing with lightning, and there's a lot of research being done on it. Saw a question on here. Oh, this is a great one. Why is lightning purple, purple and blue, or purple or blue? So lightning itself can take on a lot of different colors. A lot of times the lightning itself, if we were just looking at it, the actual light of it would probably be closer to just white, but the storm clouds itself typically have more of that purplish or bluish coloring to it. And so that's one thing that just kind of like a storm cloud, if we're looking at it during the daytime, might have that blue coloring to it. A lot of the times that lightning is going to take that on too. But there are cases where we can get rain, or we can get some weird coloring in the sky to where there can even be pink lightning. That happens during thunder snow, which is a really rare thing, but that can happen sometimes. And also orange lightning can also happen too. What can lightning do to you if it hits you? If lightning hits you, same thing. It's going to try to do if it hits you, it's trying to find the quickest way to the ground. So electricity is probably going to very quickly go through you, or maybe go on the outer edge of your skin. Sometimes it does that, and it can cause some burns, and it certainly isn't a whole lot of fun. But because lightning is so quick, even though there's a lot of heat, a lot of electricity with it, because it is so quick, a lot of times most of the time humans survive it, but it can still burn you. Can you go blind from lightning? I've never heard of anybody going blind from it, but I can tell you if you get a real big bright flash right in front of you, almost temporarily, if you're kind of looking around, you can still kind of see almost like a black shadow of that lightning, just kind of almost stuck in like a silhouette of that lightning just kind of stuck there in your vision. Sarah asking, how thin is lightning? And believe it or not, it's thin, very thin, about the size of a pencil. I know that sounds crazy because when you see it in the sky, it does not look like that, but it's a little bigger than the size of a pencil, where the actual electricity is at when it actually hits the ground. So if that hits, say, a car or a tree or anything like that, if you actually were to look at the imprint, that's what you would see, is kind of that little zap mark. Really neat thing, if lightning, because it's so hot, if it hits the beach, say down in Florida, or even maybe out in like Maumee Bay State Park, right? If we're out there, if lightning hits the sandy beach, it's possible that heat can actually lead to that sand almost coming together and fusing together like glass. And you can almost kind of see like a spider web, kind of like a lightning type of shape in the sky, in the sand, as that electricity spreads out. Really kind of neat. But it is really small, which is another way that researchers kind of figured out that lightning isn't as big as what we think. Puts off a lot of light. It looks a lot bigger than what it actually is. How big is the biggest lightning strike? So the biggest lightning strikes are they're all about the same width, but that lightning, as it spreads out across the sky, sometimes can go for miles and miles and miles. And usually if it hits the ground from a cloud, it can only go so far, right? It can only maybe go a few miles. There's not a whole lot of room for it to go. But if there's a big, long storm front and that lightning can kind of crawl right along that front, sometimes it can go for 10, 20, 30, 40 miles. There have been cases where that has actually happened. So I think the record is something like over 100 miles. But it can go a really long way if it can start to do kind of that horizontal spread through the sky. Let's see here. How often does lightning hit Michigan? So in Toledo, we usually get about 35 days out of the year where we have lightning, where we have storms. And in Michigan, southern Michigan is generally closer to about 30 or 32. And then as you go into northern Michigan, it drops down to like 20, 25 as you get up towards the UP of Michigan. So it's a little bit lower there. Let's see. What does lightning get drawn to the most? So Mary was asking this. So lightning gets drawn to the tallest object, and it does like to go towards metal of some sort. So it does, because metal is a conductor, it is able to kind of bring that charge in a little bit quicker. And if you've got a tall metal object, well, then that certainly is more of a target. So like we had thunder snow, which I know we've had some questions about. Hey, can we get like severe weather or storms kind of mixed with winter weather? Well, thunder snow is exactly that. You have the ingredients for a thunderstorm and the ingredients for snow that overlap. And so it is a thunderstorm where it snows instead of rains. And it is fascinating. I love thunder snowstorms. They're really, really cool. But the last time we had one, we only had one lightning strike, and it hit our tower. Our tower out in Oregon is like 940 feet, 960 feet up into the sky, and it is by far the tallest thing all the way around it. And it does get hit by lightning pretty often here. Let's see here. Kelly asking, what's the biggest tornado? Biggest tornado, at least the widest tornado that we've had, was a little over 2.5 miles wide out in El Reno, Oklahoma. I believe that is the widest tornado. So widest tornado I can ever remember. That was 5, 6, 7 years ago, something like that. It's been a few years now. Let's see. From Katie or Caitlin, hopefully I don't know if I said your name wrong, from Alicia here on her Facebook account, asking how often do people get struck by lightning? We get about 5, somewhere between about 300 and 1,000 people get struck by lightning in the United States in a given year. Now, it could be directly, that could be the lightning struck 20 feet over there and hit a tree, but I still got zapped or got shocked from it. So it may not be a direct hit, but almost all of them end up surviving it, but they can get burned from it. So there's hundreds of people in a given year that actually get hit by lightning in the United States, and there's lots and lots of lightning storms that happen even at this particular time. Even though it's not storming here, there's always lightning happening around the world somewhere. Deborah, could lightning knock your socks off? Yeah, there's there's been reports where people have been hit by lightning and it zaps off and blows off somebody's boot or shoe. And then later on when they got it, they could just literally see where the lightning has come down and blew the whole bottom out of their boot and just blew it to shreds. So it absolutely can. Caleb was asking, how do land spouts form? That's a good question. Land spouts are similar to water spouts, but they're on land instead. And so a land spout is in the tornado family, but it does not form the same way. So what happens is that you end up getting a really strong updraft where the wind is going straight up into the sky really quickly, and then it hits a small area of rotation towards the ground, and it stretches it out. So the rotation starts near the ground first, and then it kind of picks up almost like a whirlwind, kind of a small area rotation, and then it pulls it all the way up towards the cloud, and then it really gets going. And it happens in areas where we have really hot weather, where we can get usually really strong updrafts more easily. And so Colorado is probably the state with the most. It seems like it happens out there more often than anywhere. It has happened. I've had it happen to me as a forecaster where we've gone on TV and let people know a couple times. And that's always a tricky one to explain because it is scary. It looks like a full-fledged tornado, but usually they're much weaker than that and don't do nearly as much damage. But they're still something that you would want to know about and want to get to your safe spot if one was developing. Let's see here. I'm going to try to update it here. Any other questions about the severe weather or staying safe? Trying to pull up the latest here on the feed that I've got. All right. So I'm only getting a few that are actually showing up here at this point. But if you've got any questions that you can think of later on, let me know. And of course, next week we'll talk all about earth science. If you still have tornado questions or severe weather questions, you can ask anytime. We'll get to those. That's not a problem at all. So it looks like one more here. Christopher, age 7, what is the longest lightning ever? So I don't have that off the top of my head, but I do. In fact, it is possible we don't know the answer to that because of how these observations are taken. But I do recall there being a very, very long lightning strike that potentially was over 100 miles long. This was a few years back, and it was kind of the same thing I was explaining earlier. It was like horizontal lightning essentially, so it was like in the clouds, and it was basically crawling up a really long storm front that developed. So it was 100 miles going from the cloud to the ground, but instead going horizontal about 100 miles, and I think it was out west somewhere, if I remember right, definitely west of here anyways. So if you're and Mary asking if I'm outside and there's a lightning storm, what do I do? You get inside. That's definitely what you want to do, and then wait 30 minutes until you see that last lightning strike, or even if you hear the thunder, you definitely got to wait 30 minutes before going back outside. So once again, if you know anybody else that may be interested in lightning, you can share this video. If you got more questions, you can ask next week, and we'll get to that, and we'll talk all about earth science. We'll talk about volcanoes, wildfires, and earthquakes, what causes them, why we don't have very many earthquakes around here, and no volcanoes, and wildfires are extremely rare here too. So, but we'll talk all about that coming up next week, starting Monday, Tuesday, and Wednesday at 11 a.m.